Okay, as promised, we're going to complete the grade 10 November 2016 paper 1. We stopped at question 4 yesterday, so we'll carry on from question 5 onwards. Okay, so in question 5 we are told, let's move that down a bit. In question 5 we are told that sketch below shows f and g on the graph where f of x, or f of x, I'll put it here, equals 1 over x minus 1, and g of x equals ax plus q, respectively, which means to say in that order. Points A, which is 1 and negative 4, B, which is 3 and 4, lies on the graph of G, which is the straight line. The two graphs intersect at point C and D. 2 points of intersection. Line DE is drawn parallel to the y-axis. It will always be parallel to the y-axis or perpendicular to the x-axis. Okay? With E on F. Okay? So E is on F. So everything given in the introduction to the sum is represented on the diagram. Okay. So what I'm going to do is I'm going to minimize this a bit so that I can work on the side here. A little bit bigger. So the first question says, show that A is equal to 2 and Q is equal to negative 2. So if you look at A and Q, as you can see, A and Q is dealing with the straight line graph. Okay? So in 5.1, you got g of x equals ax plus q. But as you can see here, A is your gradient. Okay? So A is your gradient. Yes? Morning. Okay. So A, as you can see, A is your gradient. So how do you work out A? It's y2 minus y1 over x2 minus x1. Okay. So we're using these 2 points here. Okay. So it's going to be 4 minus minus 4 over 3 minus minus 1. It's going to give you an answer of 2, which makes A2. You see, this is a show that to prove that question, we do not use this in the sum. We must end off with it. Okay. So my equation now reads at this point g of x is equal to 2x plus q. At this point I substitute one of the 2 points. I'm going to go with b, which is 3 and 4. Again, that's an x and a y. So 4 is equal to 2 times 3 plus q, where q is now negative 2, which also confirms that thing. So the equation of g of x now is 2x minus 2. Say for argument's sake you weren't successful in proving this here, you need to use that in your next question. Those values, okay? Even if you are convinced your values are correct, you must use the values that is given to you, okay, in the next sum. Alright? I'm going to take this off because I would need the space. I'm trying to keep the diagram in focus. So I've done that part, so let's delete. So in question 5.2 we are asked, determine the value of x for which f of x is equal to g of x. So in other words, when else do we let f of x equal to g of x is when we're working out the points of intersection. So in other words, we are working out these coordinates here. Okay, so when do we let f of x equal to g of x? With a point of intersection. Okay. So as we know, f of x is 1 over x minus 1 is equal to 2 over x minus 2. So all I do is I take it 1 over, it becomes 1 over x is equal to 2x minus 2 plus 1 is minus 1. You cross multiply. Okay? So it's going to be 1 times 1 is 1, 2 times x is 2x squared, and 1 times, negative 1 times x is negative x. I take the 1 over the equal sign. So as to get the quadratic equation out, I get 2x squared minus x minus 1. Trinomial. So it's 2x and x, 1 and 1. So you got minus and plus. So the first one, 2x plus 1 is equal to 0, so x is equal to negative half. Or x plus 1 is equal to 0, x is equal to 1. Which one would be which? Okay, that is the answer they are looking for. But this one here would be your negative half, and this of course will be your 1. Okay, the question was not asked to calculate the coordinates of D and E. If that was the question, I would have substituted minus half back into this equation here. I would have gotten minus 2. So C would have been minus 1 and minus 2. And I substitute 1 also in here, I get 0. D would have been 1 and 0. Okay? But that was not the question. I could have either substituted into G or in F at that point, because the graphs are equal to each other. Okay? I normally substitute in the easier one of the two to work with. Okay? So let's look at number 5.5. They say for which values of x is g of x greater than or equal to f of x. In other words, it is where f is below the graph of g or g is above the graph of f. Now, in the previous question, they asked us to work out the point of intersection so that it leads into this question here. So we need to see where g is on top of f. So looking from on top, which graph is on top? The g graph has to be on top. Which graph is on top at this point? The f of x graph, which is the hyperbola. Okay? And the g is below, looking from on top. No? So that is not what we're looking for. However, g is on top here, up until the point D, and then f is again below. No, that's not correct. Let's look at it again. G must be on top of f. G is on top of f from there to there. From negative half to 0. Then the polarity swaps. F is again on top of G. As you can see, f is on top. That's not what I want. And there G is again on top. Okay. So in 5.3, it is between negative 1 and 0, so it's continuous, so x is greater than negative 1, but less than 0 or x is more than 1. Now remember, there's an equal sign as well. Are the graphs equal at negative half? Yes. Are the graphs equal at 0? No. Why? Because there is an asymptote here on 0. So they can't be equal at 0. So I leave that 0 out, the equal sign out there. Are they equal at 1? Yes. So I put equal to as well. Okay. So that is question 5.3. Question 5.4. They ask you to calculate the length of DE. That's the length I want you to calculate. Now there's one of two ways of calculating DE. It's either I can substitute the x value into f of x at that point, I'll get the corresponding y value here, and then that would be, the difference between it will be the length of BE. Okay? Okay, so going to what we just did there now, so we're going to substitute 3 into the f graph. That's 5.4. So f of 3 equals 1 over 3 minus 1, which is 2/3. So therefore, negative 2/3, no? Therefore, BE is going to be 4 minus 2 over 3, which is 4 plus 2 over 3. 4 and 2 over 3, which is 4 plus 2/3, which is 4 plus 2 over 3. Otherwise, what we could have done as well was we could have said, okay, the distance between the two graphs, BE, is equal to the G graph, the G is on top, minus f of x graph. So the G of x graph is defined as 2x minus 2 minus 1 over x minus 1, which is 2x minus 2 minus 1 over x plus 1. It's going to give you 2x minus 1 minus 1 over x. Now what's your x value at that point? 3. So we substitute x equal to 3. So BE is going to be 2 times 3 minus 1 minus 1/3. So 6, 5. 5 minus 1/3 is 4 and 2/3. This is a very important concept to understand and do, because that question for the algebraic expression for BE comes in often. Okay, how to calculate the length between two lines, or the distance between two graphs in this case. Okay, I'll take this off here and answer the last question. The last question says, you must write down the equation of h of x equal to f of x minus 3. So that is simple. So h of x is equal to f of x, but f of x is defined as 1 over x minus 1. So it's 1 over x minus 1 minus 3, which is this 3 here. So that is simply 1 over x minus 4. Okay. The question asks what transformation actually took place here for that given h of x equals f of x minus 3. The graph is shifting 3 units down. Okay. Now we're looking at question 6, the probability question. Question 6, we are told in a certain school there are 64 boys in grade 10. Again, they ask us to draw a Venn diagram. So the sample is 64. There are 64 children in total, boys in total. Their sports preferences are indicated below. So we got boys playing soccer. Definitely there will be boys that play soccer and rugby is the other sport. So we are told that 24 play soccer. So 24 goes there. 28 plays rugby. 28 goes there. Which means to say that set plus this part here adds up to 24. Whereas this part as well as that part of the subset adds up to 28. But if you add 24 and 28, you're going to get 52. Okay, but very important, as I have indicated, there are always people that plays both sport, unless they specify that the learner plays either soccer or rugby. Okay, so we have accounted for the first two bullets given there. In the third bullet, we are told 10 boys play both soccer and rugby. So soccer and rugby goes in the middle there. Okay, so how many plays soccer only? So it's 24 minus 10, which is 14. How many plays rugby only? 28 minus 10, which is 18. 22 do not play soccer or rugby, or no rugby. So that means to say that 22 doesn't belong to any of these subsets. So 22 will be on the outside. Let A be the boys playing soccer and B. So in other words, this here had to make set A and that had to be set B. Okay, I think that is fairly simple. At this point you can pause the video and you can read the word, and if you got it wrong initially, make sure you understand how to do this question. Okay. So that's 6.1.1. The next question is 6.1.2. Let's keep that in focus there. We are told that calculate the probability that a grade 10 boy at the school selected at random plays soccer and rugby. So if there are 64 kids to choose from, 64 boys to choose from, play soccer and rugby, so it's the overlap. Okay? So soccer or rugby is soccer and rugby is 10. So I go 10 divided by 64. That gives me 5/32. Alright. Then it says rugby or soccer. So it's going to be 14, 10 and 18. Or I can take the complement, which is 1 minus 22/64. Okay? I'm just going to go with, it's fairly simple, it's 14 plus 10 plus 18. And that is simply 14 plus 10 plus 18 gives us 42. So 42/64, 21/32. But as I said, you could have used the complementary rule, okay? Which is 1 minus the probability of soccer or rugby, which is B naught. That's a complementary rule, huh? Which is 1 minus 22/64. Okay, so it's 1 minus 22/64. 21/32. Okay. So either way, you would have gotten the full 2 marks there. And the last question, 6.3. There's another question regarding the Venn diagram. They asked, are the events a grade 10 boy play soccer at the school and a grade 10 boy play rugby at the school mutually exclusive? The question is, are they mutually exclusive? And the answer is no. Mutually exclusive, if you must draw a mutually exclusive Venn diagram, then this will be the case. There's no elements that belongs to A nor B. Okay? No elements belong to A nor B. So there's no overlap here. Okay? Or no common elements. So therefore these events are mutually exclusive. Okay? So how do you answer this question? Are they mutually exclusive? The answer is no. justify your answer, we would say that the probability of A intersection B, where the intersect is not equal to 0. When it is equal to 0, as in this diagram there, okay, so there's no intersection there, so the probability of A intersection B is equal to 0 in this case. Okay, so therefore this is mutually exclusive. However, this set here is not mutually exclusive because there are elements that belongs to set A and B, or there's an overlap in the Venn diagram. Okay, I hope you understand that concept there. In 6.2, we are told that coin is tossed twice. The coin is tossed twice, draw a tree diagram and list all the possible outcomes. So if you're looking at the coin, a coin has a heads or a tails. Okay. So what's the probability of tossing a heads on the first toss? It's 1 out of 2, 1 out of 2. So it's tossed again. So tossing a heads, you could toss a heads again, then a tails. Or if you toss tails first, you could have tossed a heads, then a tails. So this is your tree diagram. Okay, these are your branches and its probability on the branch. Okay, remember that these always add up to 1. The branches to its vertex always adds up to 1. Okay, these are called event 1 and event 2. Okay, so my possible outcomes, it's either you can have a heads or a heads, a heads or a heads, a heads or a tails, a tails or a heads, tails and a tails. Okay. Okay. So that's my possible outcomes listed there. If they'd asked you to list your possible outcomes and its probabilities, then I would have said this is equal to a half times a half, and so on and so on. But it wasn't asked yet. Then in 6.2.2, the question said, what's the probability that one of the tosses is a heads? That one of the tosses is a heads. So one of the tosses is a heads. I'm going to consider that one, that and this. So in other words, it's a half times a half plus a half times a half plus a half times a half. Just same as, okay, just put it in there. So it's going to be a quarter plus a quarter plus a quarter, which is 3 quarters. Or I can go with the complementary rule of saying 1 minus no heads. So it's 1 minus a quarter, which is 3 quarters anyway. B, both tosses are tails. That's the only option there. Both tosses are tails. So it's 1 out of 2 times 1 out of 2, which is 1 out of 2 times 1 out of 2, which is a quarter. No tails being tossed. So no tails being tossed. I must omit that, and that. The only option again I have is heads only. So it's 1 over 2 times 1 over 2, which is 1 over 4. Okay, so that basically brings us to the end of paper 1.